All right. Good morning, everyone. Sorry I can't be here today. I have a important meeting I have to be at, so apologize for not being here. But I did want to finish up this review so that you'll be prepared for the final. So my goal is to get this finished for you, and then allow you to continue to study tomorrow and be prepared for the final. Just a reminder, tomorrow is the last day to turn in any late work. So make sure you get that in. And for the final, what you see on this review is what's going to be on the final. So I'm going to go through this. This video is on YouTube, so if you want to rewatch it and then bring any questions, I will be back tomorrow to answer those, and we'll get you prepared for the final. So let's go ahead and get started. All right, here on number 15 and 16, these are very similar problems. So remember, standard form, you have to have the highest degree first down to the smallest degree. So if we label these, fourth power is going to be first, then third power, then the squared, then the x to the first power, and then last the no variable. So if we write those in order, negative 9x to the fourth plus 3x cubed plus 7x squared minus 4x minus 2. That is written in standard form now. So as we go through this example, just remember 16 is going to be very similar. So I'm going to go through that quickly. But here we go. Remember, the leading coefficient is only talking about the highest degree. So once you're in standard form, then it's the first one. A lot of people missed it on the test because they wrote the leading coefficient just that first number out in front. For this one, it was negative 4. And that is incorrect. It has to be in standard form if you're going to use that logic. A good way to remember is it goes with the one with the highest degree. The highest degree here is 4, so the leading coefficient is negative 9. The degree is the highest power you see, which is 4, and the number of terms, we have 5 of them. Over here in standard form, I'll go quicker. Remember, you do not put the zeros in for placeholders. That's only for division. So in standard form, you do not do that. So 86a to the 6th minus 4a cubed minus 7a plus 12. Our leading coefficient is 86, our degree is 6, and the number of terms is 4. Okay, so I know this is having a hard time keeping up with me, but go ahead and fill them in here. All right, and just remember, if you have any questions, bring those tomorrow.
Please stand for the pledge. Ready? Salute. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, Panthers, it's time to tune into Mohawk News. Use the link in our Instagram bio or on our website. Have a good day.
All right, so on these simplifying expressions, some people made this way harder than it needed to be. This is not multiplication. You're not multiplying two trinomials together. There is a subtraction symbol between there. So nothing happens to this first trinomial. You can drop the parentheses, but this negative gets distributed to the others, and then you just collect like terms. So we have 9v minus 7v squared minus 2v cubed minus 3v minus 2v cubed plus 6v to the fourth. And now you just collect like terms. So we have 6v to the fourth, negative 2 and negative 2 is negative 4v cubed. We have negative 7v squared minus 3v. Oh, no, because that's a 9v with it. So that's a plus 6. Plus 6v, and that is it. Likewise, on the next problem, number 18. So again, we have 3 polynomials. The first 2 are being added. The last one's a subtraction. So the first two, you can drop the parentheses. There's no need for them here because when you add, nothing changes to that polynomial. But when you subtract, you have to distribute that negative, so it becomes negative 2z plus 8z squared. Now you just have collect like terms that you have to do. So we have a negative 5z cubed plus 3z squared. And then we have a 5 plus 3 is 8 minus 2 is 6. And then a negative 1. All right, on number 19. This is just a simple distribution because we're multiplying. So we just have to multiply that by each term inside. So we have negative 6x to the fourth minus 12x cubed y plus 6x squared y squared. On number 20, we need to multiply the first term by everything in the trinomial. Then we need to multiply the second term by everything in the trinomial. So we have negative 9y cubed plus 12y squared plus 12y plus 15y squared minus 20y minus 20. And if we collect like terms here, let me grab this and move it over. We'll get a little bit more room over here. If we collect like terms, we have negative 9y cubed plus 27y squared minus 8y minus 20. And so that is your final answer. All right, moving on to the division. The first one, it wants you to use long division. So I'm going to go over here. Oops, I keep moving the wrong thing. I'm going to go over here and view the work over here on the right side. So let me write this out really quick. We have 2x minus 6, and we have 2x to the fourth minus 6x squared plus 3. All right, so let's go over here on the side and do this, do the work over here. Now remember, when you're using synthetic division, you have to have the placeholders in the proper place. Just like if you were to divide 3 divided by 108. You can't write that as 3 divided by 18 because each number has a placeholder. 18 and 108 mean two different things. And when you're dividing, you're talking about the placeholders of 1, 10s, 100s, and so on. You have to hold those placeholders. You can't just skip the number even if there's no 10s here. So just like that, in this problem, we have to put those placeholders there. So when we do that, we had 3 steps that we needed to do. So we needed to divide, then multiply, then subtract. And we've repeated those over and over and over until we got to a remainder. So the first step here, take your first terms, 2x to the fourth divided by 2x gives you x cubed. You then multiply that, x cubed times 2x minus 6, which gives you 2x to the fourth minus 6x cubed. When you subtract these, it changes the sign of everything inside. And so it changes the negative 2x to the fourth plus 6x cubed. So these terms cancel out, and you're left with 6x cubed. Bring down the negative 6x squared, and you repeat those steps over and over again. So for the second one, we divide 6x cubed divided by the 2x. So 6x cubed divided by 2x gives me 3x squared. Now I need to multiply that 3x squared by the 2x minus 6. When I do that, I get 6x cubed minus 18x squared. Then I have to subtract, which changes the sign of everything. Those two terms end up canceling out, the 6 and negative 6, and we're left with 12x squared. Bring down the 0x. And we've completed 2 of the cycles. Third cycle, we're going to do 12x squared divided by 2x. 12x squared divided by 2x gives me 6x. So I add that to my answer. Again, multiply 6x by the 2x minus 6. When I do that, I get 12x squared minus 36x. When I subtract, those signs change, and the 12's x squareds cancel out, the positive and negative. 0 plus 36 is 36x. Bring down the 3. And now we do our last cycle here. So we're going to divide, let's see, choose 36x divided by 2x. Gives me the 18. And then I need to multiply for step 8 that 18 times 2x minus 6. When I do that, I get the 36x minus 108. And so you have to take the subtraction of that. When you do, you change the signs, and you get 111. This is our remainder. So our answer is x cubed plus 3x squared plus 6x plus 18 with a remainder of 111 over our original divisor, 2x minus 6. And you have to remember, there is a remainder here that is not 0, so we do have a restriction. So 2x minus 6, we need to find out when that equals 0. We add 6 to both sides. we get 2x is equal to 6 divided by 2. X cannot equal 3. So this is our domain. X cannot equal 3. All right. So let's go over back to the synthetic division. And we have k cubed plus 5k squared minus 21k plus 14. And we're dividing that by k minus 2. All right, so let's go do the work over here on the side. All right, so remember when we are doing synthetic division, we want to know when this is 0, and that's when k is equal to 2. So 2 is the number that we're going to put in that bracket. So we're going to end up synthetically dividing by 2. And remember, we have to use our coefficients, and if we're missing any terms, we have to put a 0 in, just like long division. So our degree is 3 here, and we go 3, 2, 1, 0, so we have all of our terms, and the coefficients are 1, 5, negative 21, and 14. In synthetic division, you bring down that first number, whatever it is, and that's what you start the chain reaction with. And so you're going to do 1 times 2, which is the 0. So 1 times 2 is 2. Then you're going to add 2 plus 5 is 7. 7 times 2 is 14. 14 minus 21 is negative 7. Negative 7 times 2 is negative 14. 14 minus 14 is 0. So I have a remainder of 0, which means that this evenly divides. And it also means that I don't have a restriction because it evenly divides. That means that a factor of this is k minus 2, and so the numerator and denominator is going to end up canceling out. So if I write this as my answer, I started with a k cubed, and so my answer is going to start with k squared. So k squared plus 7k minus 7 is my answer. What does that mean? K squared plus 7k minus 7 times the k minus 2 gets you the original k cubed plus 5k squared minus 21k plus 14. All right. So if we go back to number 25 here, all right, so on number 25, it says list all possible roots and then find all the zeros by factoring. So if we just look at the factoring part, because on the final, we're not going to have a list all possible roots. So we just want to focus on the factoring, finding the zeros. So if we do that, if we end up factoring out a negative x, we're left with x squared minus x minus 6. You might be asking, why did you factor out a negative x and not just an x? Because I want to use the diamond method if at all possible. And in order to do that, a has to be positive 1. So in this case, if I have negative 6 on top and negative 1 on the bottom, those factors are negative 3 and positive 2. So I have negative x times x minus 3 times x plus 2. If I set each of those equal to 0, then my roots are x is equal to 0, 3, and negative 2. So those are my 3 roots where the graph crosses the x-axis. Over here on number 26, These are 4 terms. 4 terms should be a red flag to you. Try factor by grouping. So if you do this, if you factor out an x squared, you're left with x minus 1. So I want to get this matching term on the right side. So in order to end up with a 1, I need to factor out a negative 1. I need to factor out a negative 36. So negative 36 times x minus 1. And so then if I factor out an x minus 1, I'm left with x squared minus 36, which is a difference of squares. So that is x minus 1 times x plus 6 times x minus 6. So x then is equal to 1 and plus or minus 6. So those are your 3 roots from this problem. On number 27 here, I want to use the AC Diamond method here. So if I do 9 times 16, I get 144. So if I have 144 on top, and I have negative 40 on the bottom, this is negative 36 times negative 4. Because negative 36 times negative 4 gives me positive 144. And if you add negative 36 minus 4, you get negative 40. So I'm going to rewrite this with this negative 40 replaced with these 2 terms. So I have 9x to the 4th minus 36x squared minus 4x squared plus 16. So what I want to do is factor out a 9x squared here. When I do that, I'm left with x squared minus 4. Over here, I want to factor out a negative 4, and I'm left with x squared minus 4. If I factor out this x squared minus 4, I'm left with 9x squared minus 4. Both of these are difference of squares. The first one is x plus 2 times x minus 2. And the second one is 3x plus 2 times 3x minus 2. And if you set all 4 of those equal to 0, you get x is equal to plus or minus 2 and plus or minus 2/3. So those are my 4 zeros. Plus or minus 2, plus or minus 2/3. All right. So if we look at this number 28, given one root, find the remaining roots. What does a root mean? That means that it is a 0 of this graph, which means it has a factor. So x plus 2 is the factor where negative 2 is the root. So if negative 2 is the root, x plus 2 is a factor, which means that we can divide this. So if we use synthetic division here, negative 2 on the outside, because that's our 0, and then our coefficients, 1, negative 7, 2, and 40. Don't have any missing terms, so I don't need to add any zeros in there. Bring down the 1. 1 times negative 2 is negative 2. Negative 2 minus 7 is negative 9. Negative 9 times negative 2 is positive 18. 18 plus 2 is 20. 20 times negative 2, negative 40. 40 minus 40 is 0. So if I write this as my answer, x squared minus 9x plus 20, that should look very a very nice quadratic for you, where you can look at solving it by factoring using the diamond method. So if you have 20 on top, negative 9 on the bottom, Factors of 20 that add up to -9, they both have to be negative. So -5 and -4, because -5 times -4 is +20. -5 minus 4 is -9. So the factors here are x minus 5 times x minus 4, which, if we look at solving those, because those are two more factors, I can find the two more roots from it. So then x then is equal to 5 and 4. So we have three roots: -2, 4, and 5. All right. Next up, 29, 30, 31, 32 are all very similar. These are just about identifying the graphs. And so you need to remember, these are things you just have to memorize or conceptually understand about the graphs. So even or odd tells you the end behaviors. If it's even, they're going to go in the same direction. If they're odd, they're going to go in the opposite direction. So the first one, they both end up going up on the left and right. So I know that that's going to be even. And on number 30, they go in opposite. The left side goes down, the right side goes up. So I know that's going to be odd. So I'm going to go ahead and circle those. Now let's jump to 31 and 32 to do the same thing. 31 goes up on the left, down on the right. So those are opposites. So that's odd. And 32, they're both face down. So that means that they're even. They're going the same direction. So now let's look at the leading coefficient. Leading coefficient, if they both go the same direction because they're even and they go up, then the leading coefficient must be positive. Because if it was negative, they would both go down. So you circle the positive here. All right, now on number 30, we have them going in opposite directions, gives us the odd. And so we need to look, are they performing their normal function here? Are they performing what they're supposed to perform? So if they are, the negatives should be negative and the positives should be positive like they are here. So the left sides are negative, they go down, that's negative. The right side's positive, it goes up, so it's positive. So that means that the leading coefficient must be positive because they're doing the appropriate action that they're supposed to be doing. All right, give me 1 second because it's not popping up. Close this out, reopen it. All right, let's see if it pops up this time. Not seeing it. Okay. That's because I was circling the wrong ones on my side. Okay, let me do this over here. So again, they're both going up, so it's positive, and they're doing the appropriate action. There we go. And the second one's positive. So leading coefficient are both positive in number 29 and 30. 29 is even, 30 is odd. So if we look at the next set, the negative values don't do what they're supposed to do. They don't go negative, they go positive. So that's an inverse relationship. Likewise, the right side is positive and it's supposed to go up. So it's doing its inverse relationship, which means that the leading coefficient is causing it to do the inverse, which means it's negative. Likewise, over here on the degree is even, they're both facing down. So just like chapter 2, when A is negative, it goes down. All right. Number 33. So it says use synthetic division to find P. So synthetic division tells me that I need to use -5 and divide by my coefficients here, 1, 6, P, and -10. I need to verify I'm not missing any terms. I have an x cubed squared 1, 0. So I'm good. So let's just synthetically divide and see what we get. Bring down the 1. 1 times 5 is negative 5. 6 minus 5 is 1. 1 times negative 5 is negative 5. And then when you are dealing with columns, you're adding. So this really means p minus 5. And I know that if it divides evenly, this must be 10 because I need a 0 remainder. So p minus 5 times negative 5 is going to get me 10 because that's how synthetic division works. So if we take that logic, negative 5 times p minus 5 will give us 10. Now it's just something simple to solve an algebra problem. So I'm going to distribute the negative 5. So I have negative 5p plus 25 is equal to 10. Subtract 25 from both sides. And I get negative 5p is equal to negative 15. Divide by negative 5. And I get p is equal to 3. So find p. This must be 3 for this to be a root. So if negative 5 is a root, p has to be 3. All right. Using the quadratic formula. Quadratic formula, x is equal to negative b plus or minus square root of b squared minus 4ac, all divided by 2a. Remember, it has to be equal to 0. It states that ax squared plus bx plus c is equal to 0. That's what it states in the formula. So you have to have it equal to 0 in order to use this. So if b is 6, then negative b is negative 6 plus or minus square root of 6 squared minus 4 times a, which is 2, times c, which is 3, all divided by 2 times a, which is 2. So I have negative 6 plus or minus square root of 36. And then we have 4 times 2 times 3 gives me 24. Divided by 4. So if I bring this up over here, I have negative 6 plus or minus the square root of 12 over 4. Now 12 is not a perfect square. I can't take the square root of 12 and get a whole number. But it has a factor that is a perfect square, and that's 4. So 12 equals 4 times 3. So if I replace this, negative 6 plus or minus square root of 4 times 3 over 4. The square root of 4 is 2. So I have negative 6 plus or minus 2 root 3 over 4. All three of these terms, negative 6, 2, and 4, are divisible by 2. So to simplify, I get x is equal to negative 3 plus or minus the root 3 over 2. And so that is my final answer. Negative 2 plus or minus root 3 over 2. Next up, I have to have it equal to 0. So I have to subtract 1 from both sides. When I do that, I get 3x squared minus 2x plus 7 is equal to 0. Now I can use a quadratic formula. So x is equal to negative b. So negative 2 is a positive 2 plus or minus the square root of b squared. So negative 2 squared minus 4 times a times c, all divided by 2 times a. So x equals 2 plus or minus square root of, we have 4 minus, and then we have 4 times 3 times 7, which is 84, over 6. X is equal to 2 plus or minus square root of negative 80 over 6. And this is where normally when we were teaching this chapter, you would have wrote um, no real solutions. But since then, we've learned about imaginary numbers. So if we factor out a negative here, we get I. And square root of 80 is not a whole number, but square root of 80 equals 16 times 5. Because 16 is a perfect square, I can take that out. So I have 2 plus or minus 4 root 5I over 6. So I took square root of 16, which is 4. Square root of 5, I can't reduce. And then negative gives me the I. So you get, everything is divisible by 2. So you get 1 plus or minus 2 root 5I over 3 is your final answer. All right. Over here on number 36, in order to add or subtract fractions, you have to have a common denominator. So we need to factor these to see if what our factors are. So we have negative 16 on top. We have negative 6 on the bottom. This is negative 8 and positive 2. So this really means x minus 8 times x plus 2. Over here, we have 8 on top and 6 on the bottom. That is 2 and 4. So this really means x plus 2 times x plus 4. So if we look at this, we have x minus 8, x plus 2, and x plus 4 as my common denominator. So x minus 8, x plus 2, and x plus 4 as my new common denominator. The left side is missing the x plus 4. So I need to multiply x plus 4 times top and bottom. So I have x plus 4 times x plus 1 minus, I have an x plus 1 times the one on the right is missing an x minus 8. So if I multiply this out, I get x squared plus 5x plus 4 minus x squared minus 7x minus 8 over the x minus 8 times x plus 2 times x plus 4. So if I distribute this negative through, I have negative x squared. I have x squared minus x squared is 0. 5x plus 7x gives me 12x. 4 plus 8 gives me 12 over the x minus 8 times x plus 2 times x plus 4. If I factor out a 12, I get 12 times x plus 1 over x minus 8 times x plus 2 times x plus 4. Where x cannot equal 8, negative 2, and negative 4. So that is my final answer. 12 times x plus 1 over x minus 8 times x plus 2 times x plus 4, where x cannot equal 8, 8, negative 2, or negative 4. Excuse me. All right, this next one I will do tomorrow because I'm running out of time here. So I'm going to jump to. Actually, I will finish up both of these tomorrow. So we'll have two problems that we'll cover tomorrow, number 37 and 38. And I will see you tomorrow. Great job. Whatever time is left, you can study as well as making up any assignments. Remember that tomorrow, Tuesday the 13th, is the last day for you to hand in any late work. Have a great day. We'll see you tomorrow.